Hello, good morning, and welcome to the presentation of the Index Shell project. My name is Bulu Atife Adeshina, and I'm here with Team Enigma with Jere Joshi.
Hello, I'm Joshi.
Hi, this is Prithvi.
And we'll be taking you through the project, just showing you what we've built, what we've had built during the semester, and what we've learned, and how we got through the issues that we had. So yeah, I'll take you through the slides. All right. So the name of our project is called Index Shell. And let me start with one question. Have you ever needed that one command? You know, that one that keeps slipping your brain, that you need to use it basically every day in terminal or in any other kind of shell. And you find so tedious having to find and look for it and type it all the time. Sometimes I have to Google it and then copy and paste it. It's very tedious, isn't it? Right? What if you never had to do that again? What if you had a one-stop shop for every command that you used on a quite often on a regular basis? You'd have a list of them and you could access them whenever you want. That's where we come in. Index shell is the remedy to this issue. It allows users to store any code snippet that they use frequently, tag said code snippet with any useful or helpful keywords that could help you find it, and allow users to retrieve said snippet just by looking for it through our application. With this solution, it should actually reduce drastically the need to either go on ChatGPT and look up code or even on Stack Overflow to make sure that we're using the correct command. We can just visit Index Shell, which is essentially a new source of truth for a daily developer. All right. So next thing, I'm going to talk about the features and components that make up this application. First and foremost, let's talk about the features that actually make the index shell quite powerful. First, security. We understand that some code snippets might contain sensitive information. It's the worst thing in the world to have your proprietary code out on the internet, and we took steps to make sure that any code in Index Shell is protected. So first and foremost, we have all our web pages secured with HTTPS, right? A secure connection, and we also, as you'll see later when we do a demo, we are able to handle concurrent sessions without affecting the either the security or the speed of the application. So, and all our web pages also are secured by uh, they all check for a token before they pass along any information. Next, we have scalability. IndexShell is designed to handle multiple concurrent sessions at once without affecting the speed, the responsiveness, or the results that you get back from the application. And yeah, next, I'm going to show an architectural diagram, an architectural overview. First and foremost, we this is the diagram of the application that we worked on. If you can pause and look at it, but I'm also going to go through it in more detail next. Excuse me. So first of all, the we have AWS Cognito. We used it to handle sign up, to make signing up and multi-factor authentication much easier. We also use AWS Lambda, which handles a lot of actions that occur whenever we've created a snippet. You know, we've entered a snippet into the database, or we're trying to retrieve anything from said database. AWS Lambda is the direct propagator of those actions. We also have an API gateway, which is connecting directly to Lambda, triggering the correct APIs that would our database or our backend would operate on, would respond to. That's how we're linking those two things together. Then we also have S3, which is a primary storage bucket for our snippets, but also it also houses the static web page that is the front end of our application. We're exposing that to the internet via using AWS S3. And lastly, we also have AWS Elasticsearch, which housed the main schema for the database, making it essentially our own mini database that we're using for this application. So next up, we're going to actually do a demo of the application, show you what it looks like, and to do that, Joshi is going to come up. Thank you.
Hi, I'll be starting with a demo of the application. So yeah, this is the front page of our application. Enigma, index yourself. Let's start. Yeah. This is first for searching through the database, and this is for inserting new snippets. Uh, so let's try these. Command here, submit. So there will be a tagging algorithm lambda in the background. It will be calling Gemini API, which will be tagging this algorithm, giving it a summary, removing any sensitive data. Yeah. So yeah, that's the snippet created for this command. Now see, these are the tags generated. I can use these tags to search this snippet in the database now. Let's say I search for rsync. Search. Yeah, see? And if you can notice here, this is a description. Now, if in case you want to go through it, now I'll be showing you how a new user can register. Delhi Ray at the rate. Okay. Yeah. Gmail.com. So yeah, the new user which has just been created has logged in now, and I just added a command from the first user I originally logged in with. Now this user can also search the database for the same command. If I search rsync here, I'll get the same result. See, yeah, that's it for the demo. Now Prithvi will be taking over to give the technical description of our project.
Hey everyone. So thank you so much, Joshi, for the demo. Now let's dive deeper into the technical details that make IndexShell a robust and a reliable tool. So first, let's talk about the backend architecture. Our use of AWS Lambda ensures that application remains serverless, which means lower cost and easier scalability. So Lambda functions are triggered whenever a snippet is added or retrieved, ensuring that its operations are efficient and seamless. So now also the API gateway, which plays a critical role in this process, acting as a front door to our application. It handles all the incoming traffic, routing them to the appropriate Lambda function. This is not only streamline the process, but also adds an additional layer of security, ensuring that only authenticated requests are processed. So now let me show you some search algorithms in AWS Lambda function that performs the search operations on the users and the snippet tables in the DynamoDB table. So the function process incoming, the HTTP GET request, validates the search input, searches the respective tables, and then return the JSON array of snippet value as the response. So the search functionality primarily relies on DynamoDB methods to minimize the need for complex logic within the Lambda function, aiming for an efficient search operation abstracted by DynamoDB, as you can see. So coming to the tagging algorithm, for tagging, summarizing, and managing code snippets, it supports efficient reuse of common snippets across users while allowing users to maintain personalized version with custom tags and summaries. So basically, upon receiving a snippet, the system check if it exists in the shared database. If it doesn't, the snippet is processed, tagged, summarized, and stored. If a user provides a custom tag or a summary, These are stored in their personal database while keeping the shared snippet intact, which is important. So now I will briefly talk how we have utilized DynamoDB in this project. In the tagging algorithm Enigma, DynamoDB is utilized as the primary database to store and retrieve snippets and user-specific data. The algorithm operates with two main tables, which are snippets and users, as you can see here, which serve different purpose. The snippet table act as a immutable single source of truth for storing command snippets. Each snippet in this table is uniquely identified. The user table stores user specific data, particularly their custom snippets and associated metadata. Each user is identified by their email address. So now let's talk about security. It is top priority for us, which is why we have implemented AWS Cognito for user authentication. So Cognito not only manages user sign up and sign in, but also handles token based authentication, ensuring that only authorized users can access the store snippets and nobody else. So lastly, the scalability is built into every fabric of index shell. The use of serverless architecture and AWS managed service means that our application can effortlessly handle a growing number of users and requests without compromising on performance. Whether it's a single developer or a large team, Index scales to meet their needs. In summary, Index Shell is designed to be secure, scalable, and highly efficient, making it a valuable tool for any developer looking to streamline their workflow. We are confident that it will become an indispensable part of your daily development routine. So, thank you so much. And from here, Bolu will take it on.
All right. All right. So to conclude our presentation, we hope you've seen how index shell can be helpful, can be useful for developers around the world. Pretty much, it fulfills a quite essential need, and it's not just a tool, but it's a comprehensive solution to a common developer challenge. From security measures that we implemented to the scalable architecture that supports your growing needs, every element of index shell has been really carefully considered and designed with the developer in mind. Whether you're working solo or as part of a larger team, Index Shell is here to make your life easier, more secure, and more efficient. We're excited for you to experience the time saving and productivity like enhancing benefits that comes with using Index Shell on a regular basis. Thank you for your attention and for watching this video, and we look forward to your feedback.
Thank you.
Have a great day.
Thank you.
Thank you.